Nvidia is no longer just selling the chips that power the AI boom. It is increasingly helping finance the companies buying them. In August alone, Nvidia helped arrange roughly $500 billion in financing for customers building AI infrastructure. Then, it agreed to guarantee up to $105 billion for a massive OpenAI data center lease in Ohio. Now investors are waiting for Nvidia's latest earnings to answer a much bigger question than whether the company can sell another quarter of GPUs. Has Nvidia become so important to artificial intelligence that it is now helping finance its own market? One analyst quoted by Reuters compared Nvidia's role to a central bank for AI. That sounds extreme until you look at what is happening. Nvidia spent the first years of the generative AI boom in an almost perfect position. OpenAI, Microsoft, Meta, Amazon, Google, startups and governments all wanted more computing power. Nvidia had the chips everyone needed. Demand exceeded supply, prices remained high, and revenue exploded. But the AI industry is now entering a different phase. Building the next generation of AI systems is becoming so expensive that simply having demand is not enough. Customers need land, power plants, transformers, cooling, networking, memory, thousands of servers and financing that can last for decades. The chip is only the beginning. And Nvidia has a reason to care about every layer. Reuters reports that spending by major technology companies on data centers could exceed $730 billion this year. That is roughly the annual economic output of a medium-sized country being poured into computing infrastructure in a single year. But some of the companies consuming this infrastructure are not yet generating enough cash to fund everything themselves. OpenAI is the clearest example. It wants enormous amounts of computing capacity for future models and agents, but building that capacity requires tens of billions of dollars before the infrastructure produces revenue. Last week, Nvidia agreed to guarantee up to $105 billion to support OpenAI's lease of a huge Ohio data center over a 20-year period. The logic is easy to understand. If OpenAI can secure more infrastructure, it can deploy more AI systems. Those systems need more compute, and much of that compute may use Nvidia hardware. Nvidia CEO Jensen Huang argues that this does not amount to artificial circular financing. His position is that Nvidia has enormous cash reserves and can use them to help fast-growing customers secure data centers, electricity, and physical infrastructure. OpenAI, not Nvidia, is ultimately responsible for paying the lease. But the relationship still creates an unusual loop. Nvidia sells the hardware. Nvidia helps customers finance the infrastructure. That infrastructure creates demand for more Nvidia hardware. And Nvidia benefits again if the AI companies occupying those data centers grow. This is why some investors are becoming uncomfortable. There is a difference between helping a customer expand and supporting demand that might not exist without the financing. Imagine a manufacturer selling construction equipment. Normally, the customer borrows money from a bank, buys the equipment, and takes the economic risk. Now imagine the equipment manufacturer also helps arrange the loan, guarantees the building lease, and invests in the customer. The equipment is still real. The construction project may still be profitable, but it becomes harder to determine how much demand is truly independent. That is the tension surrounding Nvidia right now. The company is still generating extraordinary growth. Analysts surveyed by LSEG expect Nvidia's second quarter revenue to reach roughly $92.18 billion, almost twice the level from a year earlier. Data center sales are expected to more than double. And analysts expect third quarter revenue of around $104.2 billion, representing growth of approximately 82.8%. Those numbers would be remarkable for a company of Nvidia's size. But the market is no longer asking whether AI demand is strong. It is asking how long this rate of expansion can continue. That is where Rubin enters the story. Nvidia is preparing to move customers from its Blackwell architecture to its next-generation Vera Rubin platform, with shipments expected to begin this autumn. This transition matters because Nvidia cannot defend its position simply by selling more of the same GPUs. Google is expanding TPUs. Amazon has Trainium. Microsoft is developing custom accelerators. Meta is building its own silicon. Broadcom and Marvell are helping hyperscalers design specialized processors. AMD continues to attack the accelerator market. Inference workloads are becoming especially competitive because companies can design hardware around predictable model behavior and potentially achieve better economics than with general-purpose GPUs. Nvidia's answer is not simply a faster chip. It is an entire AI factory. Rubin combines new GPUs, CPUs, networking, memory, and rack-scale systems into a tightly integrated platform. The company wants customers to think less about individual processors and more about how many useful AI tokens an entire data center can produce. This is a critical shift. A GPU benchmark measures how fast one component performs. An AI factory measures economics. How much does a useful answer cost? How much electricity does it consume? How many users can the system serve? How quickly can an AI agent complete a sequence of reasoning steps? How much revenue can 1 megawatt of data center power generate? Those are the questions becoming important as AI moves from experimental training runs toward continuous inference. And agents could make the scale much larger. A normal chatbot might generate one response. An AI agent can receive a goal, reason about the problem, search information, call software tools, write code, check its work, retry failures, and coordinate with other models. One request can become hundreds of inference steps. If millions of people and businesses start using these agents continuously, computing demand could rise even if individual models become more efficient. Nvidia is effectively betting on that outcome. The financing makes sense if cheaper AI creates much more AI usage. This is the same phenomenon economists sometimes call induced demand. When something becomes cheaper and easier to use, people often consume much more of it. More efficient cars did not eliminate driving. Cheaper internet bandwidth did not reduce internet traffic. More efficient computer processors did not cause people to stop buying computers. The question is whether AI follows the same pattern. If inference becomes 10 times cheaper, but companies deploy 100 times more AI agents, total computing demand still rises dramatically. That is the future Nvidia is building for. But there is another possible future. Models could become so efficient that the industry needs far less hardware than expected. Small models could handle routine work. Distillation could transfer capabilities into cheaper systems. Software could improve utilization. New architectures could reduce memory requirements. Custom chips could take specific workloads away from Nvidia, and some AI applications might fail to generate enough revenue to justify enormous data centers. If that happens, the financial structures being created today become much more important. Debt still has to be repaid. Leases still have to be paid. Power contracts still exist. Servers still depreciate. A data center built for a model architecture that becomes obsolete does not disappear. This is why Nvidia's $105 billion OpenAI guarantee has attracted so much attention. It exposes Nvidia not only to the success of its own chips, but indirectly to the economics of the customers deploying them. Reuters reports that Nvidia has also helped arrange around $500 billion in AI infrastructure financing from 6 major U.S. financial institutions. $500 billion. That is larger than the annual GDP of many countries. And it shows that the AI race is becoming a financial system as much as a technology industry. Banks provide debt. Private equity finances data centers. Utilities build power infrastructure. AI companies sign long-term contracts. Chipmakers help guarantee projects. Cloud providers invest in model developers. Model developers then buy cloud computing. Every participant depends on the others continuing to grow. That interconnected system can be extremely powerful when demand is expanding. It can also amplify problems if growth slows. This is why Nvidia's earnings matter beyond Nvidia shareholders. The company has become one of the clearest indicators of whether the enormous AI infrastructure cycle is still accelerating. If Rubin ramps successfully and customers continue ordering more systems, the market receives another signal that demand remains strong. Morgan Stanley analysts estimate Rubin could contribute nearly $9 billion in sales in Nvidia's third quarter alone. But if the transition disappoints, if customers delay infrastructure spending, or if margins weaken, investors may start questioning assumptions throughout the AI supply chain. That includes memory makers, networking companies, data center developers, power equipment manufacturers, cloud providers, and the financial institutions lending money to all of them. There is also a strange contradiction in Nvidia's position. Its success has encouraged customers to reduce their dependence on Nvidia. The more expensive GPUs become, the stronger the incentive to design alternatives. Google's TPUs exist partly because Google operates at a scale where even small efficiency improvements can save billions. Amazon has the same motivation. Meta has the same motivation. OpenAI is exploring custom hardware. Even customers that continue buying Nvidia chips want bargaining power. So Nvidia must keep improving fast enough that replacing it remains difficult. That is why Rubin is so important. Blackwell proved that customers were still willing to spend enormous amounts for higher performance. Rubin now has to prove Nvidia can continue improving total data center economics before custom silicon closes the gap. The challenge is not that Nvidia suddenly has weak technology. The challenge is that the entire industry has learned how valuable AI hardware has become. Everyone wants a piece of it, and the market is shifting from a simple GPU shortage toward a much more complicated competition involving specialized chips, networking, power, software, and financing. That may explain why Nvidia is moving so aggressively into infrastructure support. If the company only sells chips, competitors can attack the chip. If Nvidia helps build the entire ecosystem, replacing it becomes much harder. The company can support a customer before the server exists. Provide networking when the data center opens. Sell accelerators when computing begins. Offer software throughout the life of the system. Invest in the companies using the hardware. And potentially help finance the next expansion. That is no longer a semiconductor supplier. It begins to look like an economic platform. But platforms create responsibility. The more Nvidia supports the growth of the AI ecosystem, the harder it becomes to separate Nvidia's performance from the health of the ecosystem itself. That is the real test facing the company now. Not whether Rubin is faster than Blackwell. Not whether revenue reaches another record. But whether AI demand is becoming economically strong enough to support the extraordinary infrastructure being built around it. If Nvidia is right, the current spending boom may only be the beginning. AI agents could require far more inference. New models could consume far more computing power. Data centers could become factories producing intelligence continuously. And Nvidia's decision to finance customers could look like one of the smartest uses of corporate cash in technology history. If Nvidia is wrong, the same deals could become evidence that the AI boom became dependent on suppliers, helping customers afford the products they were selling them. That is why the phrase "central bank of AI" is so revealing. Nvidia no longer sits at only one point in the AI economy. It increasingly sits underneath the entire system. And now Rubin has to prove that the economy built on top of it can keep growing.